Hello, my name is Emmanuel Junju. I'm an engineer working with Sweco Norway. I work mainly with dams, hydropower, and other water-related infrastructure. I have been involved together with GIZ and the Nile Basin Initiative in developing the climate proofing guideline for water-related infrastructure, which I will be talking about in the next slides. My presentation is divided into three sections. The first section will focus on explaining the objectives and the scope of climate proofing. The second section will focus on the building blocks of the NBI's climate proofing approach. And the third section will go a little bit deeper in discussing climate proofing at the different phases of the infrastructure life cycle. The first objective of climate proofing is to look into the structure and operational integrity of water infrastructure under climate change. Dams, for example, are traditionally designed to withstand a particular or a given design flood. And in most analysis, when we look at determining the design flood, we have the assumption that there is stationality in the water series. But climate change is bringing new dimensions because the stationality seems to be disappearing, as in the design floods are expected to change due to climate change, and this causes challenges for existing infrastructure and means also new challenges for how to design new infrastructure. It means we have to take into consideration the impact of climate change, take into consideration the interventions that needs to be done on the design to make sure that they can function under climate change. We have other challenges that affect also dam safety, landslides, amongst other natural hazards that we also expect to get worse, especially if there is an increasing amount of water in the rivers. We don't only focus on increases in runoff, because in other areas you're going to have droughts that may also lead to other challenges. For example, sedimentation, the ability to actually flush out the sediments and make it very difficult for structures to achieve their service objectives, which is the next objective. The second objective of climate proofing is to ensure that the infrastructure delivers the services for which it is designed. Key among the services is irrigation, which is very important for food security, and a number of countries in the Nile Basin are highly dependent on irrigation for food production. So a reduction in water supply may mean a reduction in irrigation potential and therefore a big impact on food security. So this is something that needs to be focused on in designing infrastructure to make sure that we can harness any advantages where we have water increases, maybe provide storage or other mechanisms to ensure that crops can still be grown and that the food security is not threatened. Hydropower is an important component of the energy mix in most Nile Basin countries, and is very important for electrification, and is of course very dependent on runoff. And if there is a reduction in runoff, then it may be difficult to produce hydropower. If there's an increase in runoff, there's an opportunity, but there's also threats that have been earlier mentioned, like dam safety. So there is a real need to ensure that we deal with these threats from increases and also from decreases. Other threats I have probably not mentioned, like sedimentation, will also increase with increased runoff, landslides that might actually cause other dam safety related issues. So these are a number of issues that need to be looked at to ensure that the services continue. And then there is flood protection and other related factors like bridges, culverts, and erosion that threaten settlements. Already we see a number of landslide prone areas having more and more landslides due to an increase in runoff or in rainfall amounts. And this is probably going to be a theme that has to be looked at as we go forward. We have lots of bridges and culverts that have been designed based on historical time series, and there might be changes in future that may require a redesign or different approaches to ensure that this kind of infrastructure continues to function and provide the service for which it is designed. So that said, the overall scope of climate proofing, if I may summarize, is to enable the integration of climate change throughout the entire life cycle of infrastructure investment. And we have to do this all the way from policy, planning of individual projects, designing, and operation of the water infrastructure. We have to focus on services, structures, and maybe something even more important, the environment. The climate proofing guideline that has been developed is broad and offers a generic approach that can be applied across countries. That means that there may be different legal frameworks in different countries that may probably require different things or different aspects of water infrastructure to be looked at in different ways. That is not taken into consideration in this proofing guideline. It's more of a technical guideline that helps stakeholders doing climate proofing to actually be able to identify the risks, identify possible treatments, and I find a way to monitor whether the different treatments or the different interventions or adaptations are working. The guideline is designed for stakeholders doing climate proofing, and this means owners. Owners may be governments, private developers, operators who may just have a contract to operate different infrastructure, and also for professionals like consultants and other project development professionals who are usually used in carrying out planning, design, and operation of water infrastructure. The climate proofing guideline is adapted to the project development cycle of the Nile Basin. This cycle consists of 6 stages. The first one being creating of sector policy plans and regulation plans. This is usually something done by public entities or by the government. And then the next step is project identification, where project alternatives are studied and the best project is chosen. And then the third stage is project preparation. And on this stage, that's where we carry out the full feasibility analysis, field studies, environmental impact assessments, social impact assessments, among other studies, and also come up with a detailed design of the project. So here we are looking deep into the project, creating the components and making sure that they are robust. And then we have resource mobilization, which runs usually parallel to project preparation. The main objective of making sure that we have a financial closure for the project. And then construction, that is when we are actually putting down concrete and steel, then the physical infrastructure is being built according to the design. And here we also have ability to review a number of things as we put them down. And then we have the operation stage where the project is in place and it's running. And what we are saying is that climate change needs to be considered at each of these stages. We do not wait for the final stage when the project is in place. and start asking questions. Then we start already at the policy level. We consider climate change as we make the policies. We consider climate change as we choose the best project. Of course, it's not the only aspect we look at, or there are so many other aspects which are already looked at in the traditional development of a project, but we're saying climate risk assessment should be added as an extra step for each of these stages.